Dear students, now we are going to our second chapter, which is arithmetic function and Dirichlet multiplications. So in this chapter, let us first discuss about what is an arithmetic function and different types of arithmetic functions. So what is an arithmetic function? An arithmetic function means it is a real or complex valued functions which is defined on positive integers. Arithmetic function is a real valued or complex valued functions which is defined on positive integers. Such functions are known as arithmetic functions. So there are different types of arithmetic functions: Mobius function, Euler-Quotient function, etc. Okay. So what is Mobius function? That's our first one. It is Mobius function. What is Mobius function? Mobius function means it is defined as the Mobius function which is denoted by mu and is defined as mu of 1 equals 1, which is defined over only positive integers. So mu of 1 equals 1 and mu of n, if n greater than 1, and if the n is the product of powers of primes, suppose n equals some p1 power a1 into p2 power a2 into etc. into pk power ak, where pi are primes and a1, a2, a3, etc. ak are positive integers, means if any positive integer n greater than 1, if it can be expressed as the product of powers of primes, then this mu of n is defined as mu of n equals minus 1 power k if ai equals 1, where I ranges from 1 to k. I ranges from 1 to k and 0 otherwise. Means if all of these a's are 1s, then mu of n is minus 1 power k. If any of this a differs from 1, means it has no square factor. If n has a square factor, then what is mu of n? Mu of n should be 0. Means if n is the product of distinct primes, then mu of n is minus 1 power k, where k be the number of the primes. And if n has a square factor, then what is mu of n? Mu of n is 0. So this is the definition of Mobius function. Means mu of 1 equals 1. That's by definition. What is mu of 2? Here 2 is a prime factor. Okay, 2 can be written. 2 is simply a prime. So it is 2. What is 2? 2 equals 1 into 2, or 2 is 2. So mu of 2 is minus 1 power 1 equals minus 1. Agreed. What is mu of 3? Again 3 is a prime, simple prime. So it is again minus 1 power 1 equals minus 1. Enough. What is mu of 4? 4 means it is the product of primes. 2 into 2 means 2 square. Means mu of 4. So what is 4? 4 is 2 square. Means 4 has a square factor. If any positive integer has a square factor, then its mu of n is 0. So since 4 has a square factor, mu of 4 equals 0. So mu of n equals 0 if and only if n has a square factor. What is mu of 5? Again it is only 1 prime, so it is minus 1 power 1, 1. What is mu of 6? What is 6? 6 is the product of 2 distinct primes. 2 into 3. Okay, so mu of 6 equals mu of 2 into mu of 3. 2 into 3 means, mu of 6 equals mu of 2 into 3. So n equals 2 into n equals p1 into p2. So it is mu of 6 equals minus 1 whole square equals 1. Why? Because k, what is k here? K is 1, 2. K is 2 itself. p1, p2. Here k is 2. Agreed. Mu of 7, again it's a prime. So 7 is a prime, its value is minus 1. What is mu of 10? What is mu of 9? mu of 9 is 0. Why? Because 9 equals 3 square. It has a square factor. If n has a square factor, then its mu value should be 0. What is mu of 10? What is 10? 10 can be rewrite as 2 into 5. So it is minus 1 square equals 1. Okay. What is 15? 15 means 3 into 5. Again the product of 2 prime factors. What is mu of 15? Mu of 15 is minus 1 square equals 1. So this is the definition of Mobius function. If any integer n greater than 1 can be expressed as the product of distinct primes, then mu of n is minus 1 power k, and if n greater than 1 has a square factor, then its value should be 0. Okay. So this is the Mobius function. Now there is an important result that is regarding the Mobius function. If n greater than or equals 1, the result follows theorem. There is a theorem. If n greater than or equals 1, then sigma d divides n, d with the divisor of n, mu of d equals greatest integer 1 by n. This is the important result. If n greater than or equals 1, then sigma d divides n, mu of d is greatest integer 1 by n. What is greatest integer 1 by n? This equals 1 if n equals 1, 0 otherwise. Okay, 0 otherwise. So how to prove this one? Come to the proof. If n equals 1, what happens? If n equals 1, then n equals 1, d is also 1. So it is mu of 1. What is mu of 1? We know that mu of 1 equals 1. When n equals 1, greatest integer of 1 by 1, that is 1. So ls equals rs, means the result is proved. Okay. So when n equals 1, result is immediate. When n equals 1, d is also 1. 1 has only one divisor. So it is only mu of 1. Mu of 1 is 1. Clear? If n greater than 1, when n equals 1, greatest integer 1 by 1 means 1, it's 1. If n greater than 1, and when n greater than 1, then n can be expressed as the product of powers of primes. P1 power a1 into P2 power a2 into etc. into PR power a or Pk power a2. That's our general concept. Pk power a2, where each Pi's are primes. Then come to this sum. Then the sum sigma d divides n mu of d. Here the non-negative terms, non-zero terms. When n has a square factor, mu of n should be 0. That's from definition of the Mobius function. So in the sum sigma d divides n mu of d, the non-zero terms are come only when d equals 1. When d equals 1, there is a non-zero terms come. When, and also it comes from the divisors of n, which are the product of distinct primes. If n can be expressed, if n has any square factor, then what is its mu value? That should be 0. Okay. So the non-zero terms in the sum comes from only when d equals 1, and when d is the divisors of n, which are the product of distinct primes. So what is sigma d divides n mu of d? Means it is 1 plus, mu of 1 means 1. Okay, mu of 1 plus when d equals 1, it is mu of 1. Okay. Now, when n is the product of distinct primes, n equals p1, p2, when n equals p1, it is mu of p1. When n equals p2, it is mu of p2. So it is sigma mu of pi. Okay, means yes, it is mu of p1, p2, or mu of p1 plus mu of p2 plus mu of p3 plus etc. Okay, plus when n equals p1 into p2, or n equals p1 into p3, or n equals p2 into p3, and so on, means when n is the product of two distinct primes. So it is again sigma mu of pi pj plus etc. plus etc. plus it is mu of all the terms. Suppose it is the product of k distinct primes. So it is mu of p1, p2, etc. pk. Okay. Means the non-zero terms in the sum comes from only when d equals 1 and the divisors of n are distinct prime factors. When it is d is 1, it is mu of 1. When d is p1, it is mu of p1. When d is p2, it is mu of p2. When d of p3, mu of p3. So it is mu of p1 plus mu of p2 plus etc. plus mu of pk. Or when n equals p1, p2, it is mu of p1, p2 plus mu of p1, p2, p2, p3 and so on. So it is mu of p1, p2 plus etc. mu of pk minus 1 and so on. So if they are taken n at a time, k at a time, it is mu of p1, p2 etc. So that means it is mu of 1, 1. What is sigma mu of p1? Sigma mu of pi. What is sigma? What is mu of any odd primes? Or mu of any prime should be minus 1. Or mu of pi is, what is mu of pi? Mu of pi equals minus 1 for all. Okay. How many terms are there? There are k terms. So it is 1 plus kc1 into minus 1. Okay. Plus, how many terms? There are two terms taken 2 at a time. That is kc2 into minus 1 whole square. Why? Because pi, pj, when it is p, when n equals p1 etc. pk, mu of n is minus 1 power ak. Okay, here p1, p2, only 2 terms. So it is minus 1 square. Plus, what is the next term? It is taken 3 at a time. So it is kc3 into, it is minus 1 whole cube plus etc. plus, what about this one? It is minus 1 whole power k. So it is kck, how many? K times minus 1 whole power k. So it is 1 plus kc1 into minus 1 plus kc2 into minus 1 whole square plus etc. plus kck minus 1 power k equals 1 minus 1 whole power k by binomial expansion. That equals 0. So when n equals 1, the result is 1. When n greater than 1, then sigma d divides n, mu of d equals 0. Okay, so this is an important result. That is, if n greater than or equals 1, then sigma d divides n, mu of d equals greatest integer 1 by n, that is 1. When n equals 1, 0 otherwise. Okay.